Hey everyone, welcome to the 373rd episode of the Internet of Things podcast. This is your host, Stacey Higginbotham, and your co-host,
Kevin Toffel.
And we have probably a slightly subdued show for you today because I'm still stuck in Dallas, recovering from COVID, still testing positive, and
I'm just slow.
Kevin's here to keep things moving. So our show today, we're going to be talking about Matter because we just did a Matter panel. So we've got lots of stuff, including updates on security, which I think will be important. Also, IKEA has a new hub that they're going to launch later, Matter compliant. And we're going to be talking about 5G industrial devices because they're coming, maybe. Verizon also issued their data breach investigations report, which is everybody's favorite, oh my gosh, they hacked what now report. We'll talk about that. And we've got robots in the cloud for industrial IoT. We're going to be talking a little bit about that. Our guest this week is Jonathan Berry, who is the CEO of Goliath. It's a hardware-based IoT platform. So he's going to be talking about, thread, fragmented RTOSes. It's going to be super fun. We're also going to hear from our sponsor, the Lorawan World Expo. You'll find out when that is. And before we get started, let's hear from another one of our sponsors, Influx Data. At Influx Data, the creator of the time series data platform InfluxDB, they believe in putting the developer first. They built their time series platform with tools so developers don't have to make wholesale changes to their product or applications just to use InfluxDB. Developers can code in their language of choice using their preferred tools and wherever they are building applications, in the cloud, on-premise, or locally. If you build IoT, analytics, and cloud applications, you might want to check out InfluxDB. It has a powerful API and toolset, a high-performance time series engine, and a community of developers in both cloud and open source. Get started for free and learn more at www.influxdata.com/Stacy-IoT. Okay, Kevin, and all of y'all, I'm going to apologize again. I sound probably pretty wretched to y'all, and the audio quality is hotel room quality, so we're working. We have a lot of things working against us.
This will be a lo-fi podcast.
Lo-fi. This week, I did a panel hosted by Silicon Labs all about Matter. And we had wonderful speakers. We had people from Google, we had Amazon, we had Wemo, DigiCert, Schneider Electric, Silicon Labs, and the CSA, the Connectivity Standards Alliance, all talking about Matter. So we heard a bunch of things, and we'll have more on that on the newsletter and on the website later. But my big takeaway was we finally learned how security was going to work for the Matter standard. And I think this is really important.
It comes up a lot, too, with questions that we get, and we didn't really have the details to answer those.
Exactly. So what they're going to do, there's a couple elements here. One, there's going to be encryption. And we had mentioned encryption before. That's going to be at rest and data that's in motion. So that's important. There's also going to be this concept of device identity. So each device in the system is going to have its own identity, and that'll be validated by certificates. So this is very similar to how actually web browsers validate safe sites. There's certificate authorities, and they issue certificates that say this place is real and safe and authentic. And that's going to be the same thing that happens with devices that are Matter certified. They're going to have a certificate. Now, there's going to be different certificate authorities. It can be a manufacturer. And there's some question about this, like, hey, if Amazon is certifying its own devices, which it does now, is that enough security? Or do you want like a third party doing that? That's a question we still will be answering over time. But for now, device makers can be certificate authorities. Some chip companies are looking at doing it. So we're going to see a lot of that. And those certificates are going to be stored in a secure enclave somewhere on the device. So there's some hardware level security as well.
Which is very, very good, because we've talked before we started talking about quote unquote secure enclaves. I'd said every IoT device, every hardware bit should have a TPM, trusted platform module, or something similar to that, which would be a secure enclave is another implementation of a similar approach. So I'm thrilled with that. Although it could add cost to devices, new devices, and it could mean that's why some older devices don't get upgraded because they just don't have the hardware to support that security model.
And I think that's okay. I
Yeah,
mean,
yeah,
cheap is not always awesome. Cheap can be insecure, and uh, everything's a trade off, man.
yeah,
But
yeah.
yes, you're right. So that's how the security part is going to work. And yes, there's also still, if y'all remember, there's the blockchain ledger that they're going to have. That is going to be more about making sure that something is certified and it keeps up their certifications.
I was actually going to ask you about that because we didn't get to hear about it in the panel, and I understand why. But I was like, well, that's a piece of the puzzle in terms of maybe a consumer checking their own devices. Is it on the blockchain database? Is my device appearing there? Is it certified? Will firmware update implementations be showing up in the blockchain ledger to show, yes, my device got it? It's early, so that's why I understand why it wasn't discussed. But that may be another piece of this.
Well, and stay tuned because in the next month or so, we're going to actually have someone talking about the security implementation of Matter as a guest.
Sweet.
I know, exciting.
Because who doesn't love more blockchain these days?
I was going to say, who
I'm
doesn't love more
so over
security?
blockchain. Sorry, every news story is blockchain, crypto, etc. right now. So I think we're both a little kind of anti-blockchain in that regard. But
Indeed. We also learned through the panel, and I think this is going to be really important for developers, in addition to things like the basic Matter security, there is still going to be programs to work within like the Google ecosystem or the Madam A ecosystem. And that's important because, like Michelle Turner from Google talked about, yes, there are still going to be, we'll call it, she didn't say hoops, but hoops for you to jump through as a developer to make sure that you're still complying with Google's policies on top of Matter's policies. So that's if you want the more specific works with Google, that kind of thing. So keep that in mind. You don't have to have it, but it's a nice to have. It'll ensure your device like connects easily using Android phones and that sort of thing. What else did you find interesting or worth mentioning from the panel?
well, I think some of the audience questions that came in were really, really good and mostly answered the ones that we could cover because I think there were like 80 questions within this 1 hour panel yesterday.
Yes, y'all have
Yeah.
a lot of questions about Matter,
And they were
and
good. I mean, some people were just learning about Matter, so there were some very basic questions like, "So this replaces Wi-Fi, Bluetooth, Zigbee. Would these all go away?" I'm like, no, 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 no. But that's a whole nother issue. There was some interesting thoughts about, or a question about, and I don't think we got an answer. So that's why I raised it because I think we need to get an answer in the future. And that had to do with privacy. We've talked about security, but data privacy. And the interesting thing here is once you start letting devices work across different ecosystems, what does that do with different privacy policies in terms of services? Say you buy a device from Amazon, like Amazon makes a device, it's clearly going to work with their privacy policies, and you should be aware of those. But once you stop using it with an Amazon ecosystem, with Matter, you'll be able to use it, say, with Google or Apple or Samsung, et cetera. What happens then? Because now the data,
is shared
who's,
across.
yeah. So I know you asked me for takeaways, but that's actually a takeaway of we need to all get an answer to that question in the coming months. And we have time because nothing has changed. Matter's still been delayed to the fall of this year or spring if you're in the southern hemisphere of this year. So we have time to get the answer to that. But I want to raise it so I don't forget about it.
No, that's a good point. And now a lot of the data is processed locally with Matter. But yeah, if you're sending sensor data to a controller or to a service, then presumably they have that data. And I would think it would be governed under the services policies as well as the sensors policies. But we'll check in on that. That's a good point.
Yeah. You just segued into something else that we get a lot of questions about that was discussed. You had asked about controllers because there are Matter devices and there are Matter controllers. And this actually first came up to our readers, at least they pointed out to us that when Samsung said, "Hey, we're going in on Matter," all their press info was Matter controllers, Matter controllers, Matter controllers, because they don't make Matter devices. They don't make hardware anymore for the smart home. So everybody was like, well, what does that really mean? So long story short, my take was think of a controller as the brains or the hub.
Yes, and you can have multiple controllers in the home and they will be able to talk to each other to a certain extent. And this ties into some other things we learned, like, hey, things like routines and scenes, those aren't going to be part of Matter. Like, those aren't necessarily interchangeable. So you're not going to be able to pull some of that stuff over. But it will be easier, hopefully, to batch delete and batch add devices to different platforms. So, like, one of the things that I struggle with is, when I remove a device from my network, I then have to go to my Amazon and my Google and remove it. Sounds like I'm still going to have to do that, which is kind of a pain. But it sounds like it'll be slightly more efficient to do it if I have a bunch of devices.
Well, I think the efficiency is going to come if you decide to make a platform switch. And I say that because Michelle Turner from Google specifically said in our app, we plan to have a batch method that will pull in all of your devices from a different ecosystem. And they can do that with Matter because that's the whole point of Matter. So to add or migrate, say, from Amazon or Apple to Google, for example, should be very easy. Will all the other vendors do that? I would hope so because the capabilities are there in Matter. So I understand why they might not want to because they don't want you to move away from their platform, but that's still something they can do.
Yes. And we also, I'm trying to think about other things. We talked a little bit about services and the idea that you could build services on top of Matter. A lot of that felt very pie in the sky, which makes sense. Matter's not even out yet. We don't know. But I do think it's worth mentioning because I think that's where we could start to see real value as opposed to us just like programming things individually. So you could actually get a hub or a controller from a company that runs their software. And that software would be like energy management for your house or aging in place. And it would take advantage of all the things that you currently have and then build on that. So I did think that was interesting still in the future.
There was an interesting point for developers. And if I was a developer in this space, I might have been holding back on Matter just to wait till it finally lands and the final details get shaken out. But after hearing what I heard yesterday in the panel, I wouldn't be doing that now. I would be getting familiar with the Matter code that's available open source on GitHub. I was looking at it yesterday. It's all there. It's constantly being updated. And also a question was asked about, what can smart home developers reuse either conceptually or literally with code from things they've done working on Zigbee devices with device profiles and such. And there seems to be quite a lot of parallelism there that this is not or it shouldn't be a big effort for you to add Matter support to devices.
Yes. So, all in, good information. I think there's still obviously plenty more questions, plenty more to learn based on this. And I look forward to getting more and more of these answered. So, we'll see. In other Matter news, IKEA is planning to release a new hub that will be, ta-da, there's that controller again. It's going to be a Matter ready hub called the Dirigera. Dirigera?
I would say Dirigera.
Like a dirigible?
Sure, let's hope it doesn't explode or it's not filled with helium.
Well, I
But
was going to say the Dirigera has had a lot of leaks. I'm so sorry.
oh, you can tell it's been a long week already.
Yeah, I haven't talked to anyone for a week now.
Other than
Okay.
me.
Yeah,
And
this is
that's no
scheduled.
treat.
This hub is not scheduled to arrive until October, which is the fall. Hopefully, we'll have Matter by then. I should remind y'all, Matter is going to be released as an SDK, which is pretty unusual for a standard, but that should make it easy to implement for people who really just want to put it on things and go.
So this is actually good timing because there was another question to the panel about, think this got answered, but we knew the answer actually from prior discussions with people. What if you don't have like a Matter hub, or what if you have older devices that won't support Matter? How will they connect to your devices that do support Matter? And it's always been, well, not maybe not always, but it's for a while now, it's been in the Matter intent to have gateway devices that would bridge your non-Matter devices so they could talk to your Matter devices. And that's exactly what this is.
Yes. And this is also for fans of IKEA, this is IKEA 2.0 because the original IKEA Tråd-free hub came out in 2014, I think it was 2014. And at the time it was fine. I actually still have a Tråd-free hub. But the design decisions there were a little weird. Like you had to pair the dimmer switch before you could pair the light bulbs. And it was just kind of a strange format. So this is going to be much more, I want to say normal. You just pair things to the hub.
This should almost be plug and play. Yeah. I mean,
Yeah. And I actually liked what IKEA was doing with their smart home stuff because they really focused on things that were less high tech and more normal for people. So like smart blinds were a big focus of theirs.
yeah. As you said, they plan to launch this October 2022. The Trod free gateway doesn't go away because that will still support all the older non-Matter IKEA devices. They will have a new app to go along with this as well.
Mm-hmm.
Interestingly, at the very tail end of this press release, they plan to launch away from home functionality in the first half of 2023, which sort of surprises me because Matter's all IP based and it connects to Wi-Fi and kind of by default. So it's like, why wait, right?
Yeah,
Not a big deal.
yeah. And I am curious, like if you bought the IKEA Future smart blinds, are they going to work with this? This hub's going to have Wi-Fi. It's going to have Zigbee and Thread, so presumably it should. Some of your existing gear should work.
Right,
But
because Matter works over Wi-Fi or Thread.
yes, and those blinds were Zigbee. So,
Yeah.
woohoo. Okay, that is the IKEA news. Now, let's move to a different technology. Let's talk about 5G. I talk a lot about 5G in the enterprise space. It's been like everybody's like, enterprise 5G, it's amazing. Private 5G networks in the enterprise space. Yay. And up until probably this year, I've had a lot of skepticism about it because there's been a lot of press releases, a lot of pilots, and not a lot of actual production deployments. And one of the reasons is because there's just not a lot of 5G capable devices to run on a 5G network. But Nokia, which makes 5G equipment and has a vested interest in getting 5G out there, they're like, you know what? We hear you, world. And so they released a whole bunch of industrial 5G products. So there's an AI video camera, there are wearable cameras for workers, and there's a bunch of remote speaker, microphone, and helmet compatible headsets. Again, when you're wearing a hard hat, you need special gear. They put all this out there and they're hoping that launching a lot of this will help drive production deployments of 5G networks and actual use for 5G networks because now you have something to use it on. So I thought that was worth mentioning. Also worth mentioning for people who are just, are you feeling secure? Because you're not going to after this.
No.
Verizon recently released their 2022 data breach investigation report. This report became famous like in I want to say it was 2013 when they wrote about the hacked fish tank at a casino. It became one of like the internet's favorite talking points about cybersecurity. And it was actually a big moment for OT and IT security. So this is the most recent version of this report. And the biggest takeaways of this are, well, yeah, it's still pretty insecure out there.
Yeah, and they took 104 pages in minute detail to explain why. Oh my goodness.
Yeah. And, again, the biggest issues still are ransomware, which is sort of nice for people in the OT space, although you can get access to the OT side through ransomware attacks. The biggest attacks are credentialing attacks, then phishing, and then way down there, like 8% are exploitation of vulnerabilities, and like even less are botnet attacks. So really, you got to train your people. Is if I'm taking away anything here is stop phishing attacks.
Yeah, based on the data that they have, they said, quote unquote, the human element continues to drive breaches. 82% of breaches this year, I presume is 2021, involve the human element. So that whether it's phishing, just not being trained enough
Stolen
to,
credentials.
yeah, just a mistake, And they actually do have some really good data on how much time people are given to be trained on this type of security aspect. It just needs to be more. I hate to say it. I understand everybody's primary job is, unless you're in security, is not security, right? It's you're using your systems, whether they're production lines or public utilities or whatever else. That's your focus. But the people who are out to get your systems, that's completely their focus. And they're spending all their time on that. So it has to be a commensurate increase in time spent on the training aspect for these systems to keep them secure.
And it also has to be realistic training. So
True.
sending fake phishing emails, phone phishing emails to people is probably not
Yes,
optimal.
my wife gets them once a week and she's always so proud. I didn't click on this one.
Yay! You really, in ongoing training and discussion and examples, I think are really useful. And then also thinking about tools that can act as a buffer between people who make a mistake and the actual exploit. So that's, let's see, what else is in this report that's worth discussing, Kevin? Oh, most hackers now, I don't know what we're still thinking about hackers, but they're not out there to like pwn the system. They're out there to make money.
Oh, yeah.
Much of this is around financial gain, which we already knew. I mean, the rise of like ransomware gains.
Personally, I was disappointed to see the biggest rise in threat vectors being with basic web app attacks. And I'm saying that because I'm doing some web development training and have high hopes of being the god of all things web someday, which is never going to happen. Denials of service are still the largest attack, but all of a sudden, basic web application attacks have just started to rise over the last 3 years.
Okay, enough of that depressing conversation. We'll put a link to this in the show notes. And yeah, it's a good read. You should check it out, especially if you're in the security world or
Even if you're
if
not.
you're, yeah, even if you're not, even if you're like Stacy and Kevin,
Mm-hmm.
just have to write about it. Moving right along, let's talk about robots. Kevin, it's your favorite.
It is. It is. And this is a company that you might be familiar with, Stacy. I am not. This is Fog ROS or Fogros. Sounds like
Yeah.
Fogra.
Well, the ROS is the robot operating system,
Yes, yes.
which is,
They have a new version of their operating system, version 2. They had a proof of concept version 1 last summer. What makes this interesting, this company's approach, is instead of cramming all kinds of AI and neural network chips, compute chips, which can be very expensive and power hungry, into industrial robotics or robots of any kind, their platform basically leverages edge computing, where you can have a lot more of those chips and compute power as long as you have fast connectivity back and forth between a robot and the edge. And that just offloads a lot of the analysis to do robotic tasks, which can help make the robots smaller, cheaper, perhaps even faster because you have access to higher compute and more storage and such. So I just thought it was interesting because I haven't seen too much of this. I mean, yes, like my little vector robot, when I tell it to do something, it may have to go out to the cloud. So yes, you could say, oh, it's an edge robot, but it's the same concept just on a minute scale, right? When you put these robots that have true edge intelligence or access to the edge compute, they just at such a large scale, you can do a lot more and do it for a lot less in terms of bill of materials.
yeah, well, and from an execution standpoint, if they're pulling their intelligence from the edge instead of the cloud, that's going to be great for latency
Mm-hmm.
purposes. It's also going to reduce your broadband or bandwidth bills. And if your robot is performing a sensitive task, and there are a lot of robots out there performing quote unquote sensitive tasks for companies, it's also going to keep that data on your network. So I like this. It's very similar to the trends we're seeing with just overall edge computing and running applications at the edge. So it makes a ton of sense.
They don't really talk about machine learning here, but I'm just going to throw this out there because I'm sure this is a part of it. You could take that edge data from all those robots and build machine learning models to optimize when a robot needs to grasp something or it needs to lift something. And because you've already done it 1,000 times with these robots, so what's the most optimal way to do it, right? And because they're tapping into that edge data in that model, they could all do it as efficiently as possible.
Yes, I like it. Yeah, and you'll just get better over time in the conditions of that particular factory too,
Correct.
for the particular thing you're making. Okay, well that's enough news for this week. We're a little light because well I've been unconscious for most of this week, but it is now time for the Internet of Things podcast hotline. This is the segment of the show where we take your questions and concerns and we try to answer them. You can reach us at 512-623-7424 with your questions or concerns. And if you do this month for May, which ends soon, you'll be entered to win the Ember coffee mug, which we just picked because I freaking love this device. It's a great product. No one's paying me to say that. I just like it. It keeps your coffee hot, keeps your hot toddies hot, keeps whatever you need hot. Okay, so this week our voicemail is from Mark, and it's a good one because it talks about one of my favorite things. Let's hear it.
Hi, y'all. My name is Mark Bramhill. I'm calling wondering about, I'd love to use motion or presence detectors in my smart home setup, but the trouble I've run into is figuring out how to deal with pets who I do not want to be turning on the lights, or what room is the focus for a smart thermostat. Got a cat who likes to jump around and make a fair bit of motion, and I'm curious if y'all have any thoughts on how to best manage those kind of false signals with different sensors. I personally use HomeKit stuff for the house, as well as some Home Assistant stuff to kind of augment that for more of the automation. Yeah, would love to hear your thoughts.
Okay, Mark. I love this because we're already seeing adoption of technology that's going to help with this. So you're right. A traditional PIR motion sensor is just, it's very basic and it's good for lots of things, but it's terrible at setting things off if you have pets or ceiling fans or all kinds of things.
It's almost binary. Motion or no motion.
Yeah, that's what it does. But we are starting to see new sensors come out that use RF sensing. So either through like disruptions in Wi-Fi signals or radar sensors that measure disruptions in radar. And they will actually give you much more detail. So it's not binary. It's like, oh, this is a large object. And if it's running the right algorithms, it can even say it like if it's a adult person or
A horse,
a horse.
like Arnold Schwarzenegger has in his kitchen.
Yes, yes, just like Arnold in his kitchen. Anyway, so with these, you'll be able to have sensors that can detect motion, but also won't detect motion if it's your cat. And as an example, we've got the newest Ecobee that just came out. They've got a sensor that's a radar sensor, and that is able to detect the difference between pets and people.
And I'm going to verify that claim. I know Mark's not specifically asking about the Ecobee, but we mention it because it's a great example of the newer technology that will help with the situation. In this case, it's millimeter wave sensors. And I did check with Ecobee, and they said the sensor in the thermostat and in the remote sensors can distinguish people from pets. So that's good. And again, I'll verify that because I do have their latest thermostats in hand that I am currently reviewing. I haven't tested yet to see if my skinny cat or my fat cat will actually set it off, but I will try that. So
What about your adorable dog?
he's always like with people, so it doesn't count. Like, I mean, we literally carry him to bed because he doesn't want to go up the stairs and he knows when it's bedtime. And so a person would be there by default anyway. But
Oh,
the
Norm.
Ecobee folks did give some general advice, which I would actually say applies to any sensors in this case. They said to avoid false alerts from pets, they recommend setting your sensors on a high shelf or mounting at least 3 feet off the ground. Don't point them toward items that could trigger motion detection, such as fans or curtains. All good advice, regardless of your sensor, I think. I know Mark specifically didn't ask about web cameras, but some people do use those for presence, and most of the better ones let you mask off an area, let you say in the app, only tell me if there's motion in this area. And you basically create a little area in the app. And I never do it to the ground, I do it up high, because if a cat scurries under my garage on the pathway, I don't want to be alerted. If a person walks on the pathway, I have the mask up high enough so that I will still capture them. So that's just another, I guess I'll say, tip if you're going to use webcams in this instance. But as Stacy alluded to, the technology is, I guess, would you say just starting to roll out to improve this?
It is. It is just like things have changed in the last year or two with regards to cost, with regards to effectiveness, and even like battery consumption. So we're going to see a lot more of this. And darn it if I'm not super stoked about it. Okay. Thank you for your question, Mark. You are now entered to win that Ember coffee mug. Remember, if you would like to be entered to win, give us a call at 512-623-7424. You have until the end of the month, midnight Eastern Time. And next week, it sounds like we'll be announcing our winner. Woo! That concludes this segment of the show, but please stay tuned for our guest, Jonathan Berry, who is the CEO of Goliath, talking about hardware development for IoT. And now it's time for a message for our sponsor. This week's sponsor is the Lorawan World Expo. Hey everyone, we are taking a quick break from the Internet of Things podcast for a message from our sponsor. This week's sponsor is the Lorawan World Expo. And I have Tony Shakib here, who is the GM of Azure IoT, here to talk to us. Hello, Tony. How are you today?
I'm doing great. How are you?
Excellent. So first up, why don't you tell us a little bit about the Lorawan World Expo?
Sure. The Lorawan World Expo is the largest Lorawan event ever. It'll be in person from July 6th to 7th of this year in Paris. The theme is Discover the Power of Lorawan. And really, the Expo is the industry's most prominent event about the Lorawan technology itself, how it will drive business success, and how it can really enhance quality of life for the planet and its citizens.
Sounds great. So why are you excited about Lorawan?
I am excited about it, and we're excited about it at Microsoft because, it really helps solve challenges that we're facing with constrained battery-operated devices that tend to be the large volume of devices out there. It has the ability to cover tens of kilometers with extremely long battery life, provide device durability at a very low cost, and really help us get into new situations that it's been hard to get to, covering lots of buildings, spread out over a big campus, getting into large production environments with lots of equipment to cover, and even in agriculture, where we want to track livestock or provide field conditions.
And you are speaking at this event, so why are you excited about participating in the expo?
Well, I'm really excited because, first of all, it's in Paris. It's a great city to be in. Second of all, there are a lot of smart companies that are coming together to share ideas, talk about use cases, plug and play strategies, and, discuss ways that we can take the fraction out of deploying these high volume solutions. It's also a great opportunity for Microsoft to showcase our ideas about innovation and connectivity. Lastly, we're all over this pandemic, and it's just great to get together and see colleagues that we work together and, just see them in person.
I agree. I can't wait to see everyone in person. So where can our listeners go to register for the Lorawan World Expo?
They can go to lora-alliance.org to register for Lorawan World Expo. That's taking place on July 6th and 7th.
Hey everyone, welcome back to the Internet of Things podcast. This is your host, Stacey Higginbotham, and today's guest is Jonathan Berry, who is the founder and CEO of Goliath. Hi Jonathan, how are you today?
Good, Stacey. Thanks for having me here.
I am really excited. And first up, I have to tell our audience that I am recovering from COVID, so my voice is a little weird. And I'm quarantining away from the studio in a hotel room in Dallas. So the sound quality is not probably what you're used to in the show. I apologize. But this is going to be totally worth it because Jonathan has been with the IoT for as long or longer than I have. So Jonathan, you started in this at Nest, yes? Working at Google Nest?
Yes, that's right. Yeah, I was at Google for a bunch of years, and just after the acquisition of Nest, I got the opportunity to join the embedded team.
And you were working on networking there?
Yeah. The developer platform in general, but within the embedded group, there was a wireless team, the communications team, and they were the ones responsible for developing the networking stack, but also protocols like Thread.
Like Thread and the ancient protocol that we probably have all forgotten about called Weave.
Yes.
Then Google used that name for something else, which, again, very confusing. And then after that, you went over and worked at Particle for a while, correct?
Yep. Yeah, I joined pretty early on, working on the hardware side of things. So that's everything from the dev boards and modules, but also the embedded operating system and the wireless technology that they worked on.
Got it. So I feel like you've got really good grounding here working at one platform, then moving on to another actual IoT development platform at Particle. And then you decided to start your own IoT development platform with Goliath. So why don't you talk to me about why?
Yeah, that's a great question. And it's one of those things where if you're in the industry long enough, you start seeing patterns and opportunities. When I was at Nest, I got to learn from really pioneers in the IoT space, seeing things at scale, Particle building developer platforms, and seeing huge adoption both on the developer side as well as the commercial side. And there was a theme, and actually to the job I took before starting Goliath 2 is actually contradictory to what most people talk about, that hardware is hard. In fact, that if you're a hardware company and you're building connected devices, actually hardware is the easy part. It's the things like servers and databases and security and software updates that is really hard for hardware companies. We built our own solutions at Nest and at Particle, and they're really challenging. It's probably where a lot of the R&D was focused on. And it caused me to think about, well, why do we keep on inventing what seemed to be easy to do thing over and over again? And that's when I started to dig into the space and was the kernel of the idea of Goliath.
And what exactly was the easy thing to do? That was all of the servers and everything else, security?
So it's interesting when when be in a meeting with a potential customer and they said, well, we're a software company, we have servers and we have mobile apps. How hard is it to send a software update to a server or store something in a database? Why is it so much harder to do in IoT? I could do that myself. But when you start talking about IoT devices, and you have many guests on previous podcasts, the domain is completely different. A lot of times you're talking about tiny devices, tiny sensors that are constrained on battery. They may have kilobytes of bandwidth. So, that 10 megabyte update for your mobile app is going to take 10 hours on an IoT device. And so we start to unpack all the stuff you need to build in the cloud and translate that into the IoT world. You have to actually start from a different fundamental place. And the technology you use, the protocols you implement, the cloud infrastructure is not something you can just grab off the shelf. And so the kernel was, well, why can't you just grab something off the shelf? Why isn't there a vendor that is sort of those primitives that a hardware company can reach out for and integrate into their solution without having to build it themselves, without having to DIY? And it will work for their IoT applications.
Got it. And so that's what you invented with Goliath.
Yeah. So Goliath is an IoT developer platform, and we focus on hardware makers, hardware companies, hardware engineers. And what we said was, instead of trying to take general purpose computing that's working fine for servers and cell phones, let's start from the principle of a device. If I'm a tiny cellular device, I need to communicate securely over the cloud. Well, what protocol should I implement? How do I manage my bandwidth? How do I be efficient when I do a software update while still being secure? And we've been building out that solution for the last a year and a half since you covered us in your newsletter.
Another thing you mentioned was security and things like software updates. Can you talk about what you're trying to do to help with that?
Yeah. A lot of times people think about security and they think about, preventing eavesdropping, but actually software updates is a critical part. Whether it's you pushed a bad piece of software down to your devices or there's a vulnerability disclosed, having the ability to software update your devices in the field is mission critical. It's on the OWASP top 10. It's being pushed through legislation. Yet most companies don't think about software updates from the beginning, and it's pretty complicated, I will say, having done this now 4 times at 4 different companies. And part of our platform and what we focus a lot of our energy on is secure, reliable software updates. And if you can design in such a way that the engineers who are working on the devices and responsible for the devices have an easy way to integrate secure software updates, check. And if you can have the team that operates the devices have an easy way to manage and roll out those software updates, check, then security and software updates just become a thing that is part of your solution. And that's one of the first things we built with Goliath and made sure that it is as integrated, but also super secure from the very beginning.
Okay. And I feel like when I talk to people about, oh my gosh, IoT devices are hard, they mention a lot of things that you talk about, such as, oh, if they're battery constrained, they're constrained with battery power, they're constrained on performance and memory. And the other big thing is that these devices are hugely fragmented. So there's millions of operating systems, some custom, some popular, I should say, real-time operating systems or RTOSs that these things run. And usually that's where in the past people have focused. So I'm curious how y'all help or maybe don't help with fragmentation or your take on that particular problem.
Yeah, it's a great question. The world of IoT, the types of devices you might want to create, there's a lot of combinational options there. If you think about like smartphones, right? There's Android, there's iOS, and there's not much else. Yet there's a fragmentation of hardware. In IoT, you might be building a mobile device that needs a cellular network or a stationary device that needs Ethernet. So it does create this broad area of different platforms, different hardware platforms to choose from. And the combinations become even more complicated. And so the role of operating systems in part is to build some layer of commonality. And so when most hardware companies get started, they pick one of those operating systems, which allows them to not just move faster, but also say, well, today you might be using an ST part, but tomorrow you might be using an XP part, and our OS can help abstract that. This layer of abstraction is because the operating systems include functionality, sometimes called the hardware abstraction layer, that looks for the common features across every chip, every device you might use, and either creates a lowest common denominator, which is sometimes fine, or in more open ecosystems, like open source operating systems, the actual hardware vendor plugs it in. So if you're using an operating system that supports both ST and NXP, ST and NXP might be contributing the underlying messiness that actually makes it work with their particular device, but the OS keeps it abstract. So you as a hardware creator choose your OS, and you can either rely on that abstraction just working, so you can switch between NXP and ST, or it's actually being supported by the vendor you work with, and they ensure that it's working well. So it's almost like device drivers for printers, where when you install a new printer, it's very likely that your operating system has that printer driver, so you don't have to worry too much about it. And that's the trend we see with these hardware abstraction layers and real-time operating systems.
And everybody loves printer drivers. No one's ever had a problem with them, ever.
Yeah, that's right.
So how did that influence what you built with Goliath?
Yeah, and this is part of our lessons over the last, call it 2 years of development. At the end of the day, you're building an application that you want to send some sensor data to and maybe do a software update to update new functionality or fix a security bug. And so we're trying to sit on top of that because we don't know which customer will come in with this flavor of operating system or their own homegrown thing. And so by building on top of existing operating systems with our own software, we can tap into the hardware abstractions and the investment from all these companies and chipset vendors, like et cetera, so that we can take advantage of it and enable our users to use our secure cloud services. And so it's almost like being able to build a little adapter on top of the driver. I don't know, what's a good example? Like when you're in Chrome and you click the print button and you see a little pop-up window, Chrome is calling into the, this analogy is going to break down pretty fast, but Chrome is calling into the printer subsystem and then printing on your behalf. So it allows people to build Chrome and Firefox and Safari on the same operating system. So we pick a nice abstraction layer on top of it.
It's abstractions all the way down. It's always the case in computing.
Exactly.
Okay, and since we're talking about hardware, I feel like it's really important to talk about something that is, my gosh, 2 years in, still affecting the community, which is the chip shortage. And I'm very curious what you're seeing with your customers and even your own efforts. I know you've got people who are prototyping and building all kinds of things at Goliath just for fun. So how is that affecting the market?
Yeah, the stories are not exaggerated. Why I can't get my Xbox for Christmas kind of thing. Those are true, but for IoT creators, it's even more acute because there was a smart decision and trend for the last 5 years. Let's use commodity parts like the things they put in cars because they make it in high volume. Well, now those are in short demand and they're going to cars. And so it's deeply impacting hardware companies, whether you're a startup with not a lot of purchasing power or an industrial application who doesn't buy a lot of units. It's pervasive, and it's requiring companies to redesign even when they weren't expecting to. So in terms of what we're seeing at Goliath, people come through the front door, maybe with a greenfield application saying, I want to use part X from company Y, and we support it. Great, you're good to go. But for more mature brownfield, let's say companies with product in the market, they're saying, we can't ship our parts. We have 1,000 orders back ordered because we can't get the main MCU or the microcontroller or the modem. And so we weren't planning on redesigning for another 3 to 5 years, and we're doing it right now. And it's causing obviously a lot of cost and complexity, and even still paying those premiums and all that effort, it's still hard for these companies. So the good news is there are still lots of choices in the market for a lot of areas, and people are making the work to swap out. I think I also have some long-term positive like lessons learned, I guess, to be a little bit more single-sourced resilient. So thinking ahead in case this happens again, making sure you choose parts that you could maybe redesign around or vendors that give you a little bit more flexibility. But I think that we're going to feel this pain for at least another 2 years is what I'm hearing.
Oof, 2 more years of this. Well, let's talk about picking parts that are easier to design around because I feel like I've talked to big like Fortune 500 companies that are, maybe especially conglomerates they've built by acquiring things and they're trying to rationalize like the number of parts they support. They're trying to rationalize the number of RTOSs they support for their connected devices. And I feel like from a design perspective, that makes a lot of sense. So what would your advice be to companies who are evaluating this and being like, man, how do I decide what RTOS to pick? How do I decide what hardware parameters matter? And if I'm trying to design kind of maybe it's the lowest common denominator, maybe it's the highest, I don't know.
Yeah, that's a good question. It's a little bit of an existential one because it really depends on the kind of product you're building, the kind of industry you're in, and I can give some examples of how you might think about it differently. There are definitely different scales of products. By scale, I mean volume. So if you're in a high volume, low margin, let's say consumer area, well, your BOM cost is the most important thing. Your operating costs, your OPEX. Well, you can throw a couple more engineers if it allows you to reduce the costs of, let's say, your design and your cloud. But if you're in an industrial application, which we focus a lot more on in general, well, a $5,000 piece of equipment, whether you're using the $2 part or the $10 part, doesn't really matter. And so making that sort of selection criteria is definitely helpful. I would say that if at all you're in an industry or an application that's super specialized, so for example, cellular, right? There's not that many cellular providers you can go with. And being able to say, well, what if I can't buy any of the parts from this one vendor? Picking a way to make sure that you can, at least for a lot of money, but still possible, design out that one cellular modem for another cellular modem is something you probably should invest in. And it might cost you $250,000, but then you could ship that really expensive industrial controller. On the software side, there's more choice actually. It's a little bit easier because if you make the right decisions up front, you can wholesale change your functionality or even your operating system, which I probably would recommend. But choosing from the beginning operating systems that, one, work with the hardware you want to work with, two, give you the flexibility. So like have lots and lots of hardware it supports for that switching between the vendors, and probably the ecosystem around it. Because it's not just about the hardware, it's about the support. Is the chipset vendors providing support? Is there documentation and sales enablement tools and et cetera? So making sure you don't pick a niche one or a less prevalent one is probably a good bet.
All right. And every year I look for the data on which RTOSs are most popular. I know that free RTOS has always been up there. Amazon kind of acqui-hired the guy behind that. Microsoft bought the company behind ThreadX. And there's also like Zephyr. I don't know if people are still using Contiki. So are there RTOSs out there that are popular? Which ones?
Yeah, there's a ton of options when it comes to software. There's the commercial side, like ThreadX is commercially supported by Microsoft. FreeRTOS is and will continue to be a very popular choice among operating system developers. And Zephyr is another really popular one. Embed was pretty popular a few years ago, but seems to be waning. But if you're looking for open source options, probably the two front runners is FreeRTOS and Zephyr. Now, Goliath, we have been investing a ton in Zephyr. It's actually been our first operating system we've built into our platform, primarily for the fact that a lot of chipset vendors are members of Zephyr and contributing directly. But at the end of the day, if you're working with a chipset vendor and they say, hey, here's our free RTOS solution, you probably should go with whatever's most supported by your hardware, because that's when you're going to get the best help when you run into issues. Thankfully, with open source, those also include ecosystems and communities and people contributing. So we're pretty happy with Zephyr, and we're seeing year over year significant increase in adoption.
Got it. So we just spent a lot of time on RTOSes and chips. Let's talk about networking briefly. There are tons of options out there. I would love for you to talk about which networking protocols you're seeing in the industrial space, since you mentioned working there. What are you seeing the most interest in right now?
For us, we wanted to figure out what would be the most compelling that we could do really quickly. I mean, we had a lot of experience working with cellular. So we started it with cellular, in particular low power wide area cellular like Cat-M1 and NB-IoT. And anywhere where you have that sensor in a field or on a subgrid or in a micromobility device like an asset tracker or bike kind of thing, that seems to be growing year over year. And sales of, from what I can tell, cellular IoT modems is also increasing. So lots of cellular, in particular the low power, low bandwidth versions of it. Ethernet, we love Ethernet. People think it's not sexy. I think it's one of the super under talked about IoT communication technologies. PoE is getting really interesting. You were tweeting about single wire the other day, and that's just super reliable for an actual industrial or smart building application. And actually, more recently, we've been getting kind of out of the woodworks interest in Thread for commercial applications. And so that's part of the reason why we're excited about Thread and the Thread group. And I think there's going to be upswing in that as well.
Yeah, you recently joined the Thread group, and I know we are excited about it here on the podcast, primarily because it is the low data rate method of communication for Matter. So it's kind of surprising that people might be using it for industrial. But since you were actually way back at the beginning of Thread when it was at Google and Nest, what do you think about it? What's compelling about it for the IoT?
Thread is a networking technology. The fact that it's based on IP, the fact that it's using open standards from the power of the internet itself, allows it to be really flexible. And when you're talking about, let's say, a consumer ecosystem like Matter, that means that the companies behind Matter and the standards body, they can go build out their data models and their mobile secure provisioning. But if you're in a completely different domain, then you can use those same IP primitives to build your own flavor of what a smart building control system might look like. And so it's sort of this flexibility of being a networking stack that is designed to be developed upon is super compelling. Now, in addition to, if you're seeing any form of scale, when you're deploying local wireless networks, it's so complicated. We take for granted the sort of reliability of our TP-Links and our Eero routers for at-home networking, but networking is a really hard problem. And if you're trying to tell someone who may be a building manager or an IT team at a factory, oh, you're going to go run this wireless bunch of sensors, that's a daunting task. And the parts I'm really excited about Thread is the ability to just kind of work. It's just a reliable mesh network. You can have a bunch of sensors. You can scale up to thousands reliably, and it feels more like almost like a wired connection at that point when you have such a reliable implementation. So when trying to make a decision between, do we run a lot of cable? Do we try to invest in other wireless technology? Thread is a great option to allow you then to create your own solution around it.
Okay, yes. And I mean, I'm excited because it's low latency. It seems so reliable. I'm really, really keen on this in the home. So it makes a ton of sense for the industrial space because they've really tried, they've done a lot with proprietary and they've really tried to shoehorn things like Bluetooth and Z-Wave and some weird stuff in there. And it didn't seem to fit. So Jonathan, thank you so much for coming on the show today and sharing all this information with us.
And that concludes this week's episode of the Internet of Things podcast. Please join us next Thursday, and don't forget to subscribe. And if you can't get enough IoT news, I would love for you to sign up at www.stacyoniot.com for our weekly IoT newsletter, where we explain all kinds of things that we don't even get to on the show. Once again, thank you for listening, and please subscribe.